Bill.
Okay, recording in progress. All right. Good morning, guys. It is Monday, January 13th, 2025. Pete, what number are we at?
SolderSmoke 256. Crank it in, Robert. Crank it in, Ralph.
All right, crank it in, guys. 256. Here we are. And I am happy to report that this one comes to you in part, one third part from Solder Smoke Shack South, where I am located at the moment. Happy New Year to everybody, because we haven't, our last episode was on December 13th. Here we are, January 13th, in the new year. Happy New Year to all from the Solder Smoke crew. But it's been a difficult new year. And Pete, maybe we should start with you because you are in the kind of the eye of the tiger right there. You're in LA, close to the fires. Tell us about it.
Yes. Well, first off, to give you a magnitude, it's about 38,000 acres were burnt by the fires. There's five or six going right now, and I did the little calculation. That's 62 square miles. That's
Big.
62 square miles. And I'm reminded of something in 1962 while a midshipman went on a med cruise, and our ship was parked off the coast of Italy, and I stood shore patrol in a town called Gaeta, which is north of Naples. And there I was touring the town, and 1962, there were people still living in bombed out buildings. This
Yeah.
was 17 years after the war. So anybody who thinks a year from now all those 38,000 acres are going to be like they were before, get a grip. This
Yeah.
this is a 20 or 30-year project before they'll be all restored.
Hey,
So
listen. When I was in London, I was in London from let's say 2003 to 2007, and you could still go places in London and see shrapnel pockmarks in the masonry from
yeah,
the German
yeah.
bombs that landed there during World War II.
So
So yeah, it takes a while.
hundreds of thousands of people. This got up over 200,000 were displaced. I don't know how many are now, but where do they go?
I
I
know.
mean, we
Well, you
just
know,
where do they go?
I read that 2,000 homes were burned. 2,000 homes. It's just staggering. I mean, I look out the window here, I could see a neighborhood with maybe 50 houses, and it's hard to imagine all of them gone.
12,000 structures, Bill, is what they're saying. I don't know
12,
how many homes now.
wow,
12,000.
12,000
2,000 was
structures.
an early number.
Wow.
So, yeah, it's if you look at some of the pictures of Pacific Coast Highway, it's
Gone.
just gone, flattened
This,
from like north of Santa Monica up through Malibu. A lot of real expensive properties, and then as you get a little further back, less expensive properties, but it's just gone.
Gone.
I was in LA in '94, lived there for the '94 earthquake, 3 miles from the epicenter of the earthquake. And that hit a much smaller swath of people, but it still took years to rebuild after that. I mean, I can remember for weeks afterwards, there was rubble piled on the streets as crews were coming around just to clear up the rubble from the earthquake. So
yeah.
yeah, it's and I have family in near Pete in Ventura. Everybody's fine, and I have people down in Orange County, just south of where the fires are, and they're fine. But it's just that's the area I grew up in, spent 40 years there, so it's my
And and it's a secondary impacts as well, Bill. I was 3.5 days without electricity, and the fires were 40 miles away.
That was
Southern California Edison takes a preemptive strike and turns off the power.
wow.
You haven't, and the best way I could describe it, someone says, "What was it like?" I said, "It was like Chu Lai, South Vietnam in 1965. No lights at night, sea rations, and warm beer." I mean, that was it.
Wow. Yeah.
hey, at
Terrible.
least you had warm beer,
Yeah,
Pete.
yeah, yeah, yeah.
You know, we've had some, I guess, some good news and some bad news, and it involves the Barkhausen criteria and breaking. Pete, you're the one who told us about the Barkhausen criteria and breaking the criteria whenever you have an unwanted oscillation. So, Dean, tell us about that.
Yeah, so I had an unwanted oscillation in my heart. I started having what they call paroxysmal supraventricular tachycardia. That's a long word for means you're sitting here having a nice chat with your friends and your heart rate goes from resting heart rate to 160 beats a minute instantaneously, and doesn't stop on its own. And it is the Barkhausen criteria. It's electric feedback. So apparently, what happens is your brain sends a signal to the heart. There's a node in the center of the heart and two lower chambers of the heart. The signal divides, the heart beats, and then waits for the next signal. Well, apparently in my case, a little bit of the signal was looping back, going back through the node and causing the heart to beat again. And what do you got when you got the feedback and a little bit of amplification? You got an oscillator that runs away. It's just like a squealing loudspeaker. And uh, I had a procedure called an ablation, and this is so crazy, but they basically take you into this high-tech Star Trek surgery center. They run catheters up into your heart, they image your heart, and then they trigger the tachycardia, and they find the spot in the heart where the signal is creeping back, and they cauterize it. So they burn a hole in your heart to stop a path for the signal to go back. And what do we say? Bob's your uncle, man. I'm fixed. I was in there
Wow.
one day and no more tachycardia.
Pete, do you think this is something we could apply to our amplifiers?
Yeah,
I'm
yeah,
looking for trying to look at the bright side here. But
yeah,
Dean,
yeah.
we're glad you're fixed. You're
Well,
repaired.
let me tell you kind of what caused me to undergo this procedure in the first place, which is about 6 months ago. I ended up in the ER at the Heart Center here, and it wouldn't stop. And they used this medication called adenosine to fix it. And adenosine stops your heart for
Not
like
a good
10
thing.
seconds. No, it's terrifying. And I'm like, I do not want to do this again.
Well,
So,
on the morning that Dean was going in, I sent him a text before he went in, knowing that he was going, and I said, "Just tell the doc to break the Barkhausen criteria." And then I thought about it for a second. I put parentheses, maybe not. Maybe leave it to them.
I did tell the doc, and we got into this conversation. He's an electrophysiologist, and he says, it's amazing. He says the number of people that go into EP are also engineers. And he said when he was, and he's not an engineer. He said when he was having his interview for the fellowship, the interview, he said, you're kind of normal for somebody coming into this. He said, I didn't know if that was good or bad.
Well,
Well,
we're glad you've recovered.
well, Dean, you only have to worry about one other possible impact to the heart is when you get the bill.
Yeah. Well, no, hey, this is America. They sent me the bill before the procedure.
Wow.
And you
Gee.
immediately sent it to Blue Cross Blue Shield.
You can pay your 10% copay now or when you get to the hospital.
Wow.
Uh,
I
yeah.
I think I'll pay now. Hey,
Yeah.
but Dean, we're glad it worked out, and I'm glad you're feeling better, and that Barkhausen criteria have been broken. And Pete, never before has your advice on Barkhausen been so directly applicable here. This is amazing.
There you go.
No,
Hey,
it's fantastic.
hey, listen, I got a little bit of fantastic news here too, and it's for the first time in 30 years I have seen the Southern Cross. You see, I was into astronomy when I was living down here 30 years ago. And I was living in Santo Domingo, and I looking at the sky charts, I realized that a very prominent astronomical feature in Australia and New Zealand is only barely visible if you are at the latitude that I'm at. I'm about 18.4 degrees north. And sometimes during the summer, first of all, the skies are kind of murkier in the summer. Also, the days are a bit longer in the summer, not that much longer, but a bit longer. It turns out that the best time to see the Southern Cross from this latitude is December, January. So when we came down here this time, I started looking to the south, looking for the Southern Cross, and we had a lot of murky skies. But then, just a few days ago, I was looking, and I was looking at the right spot, and I was looking directly south, and bang, man, there it was right there, and right in the Centaur constellation, and there was the Southern Cross. So that was the first time, and I actually was able to go back through the miracle of the internet to go find my log entry, my observation log entry from December 1994 when I first saw it. So we're seeing it again, and to all of our listeners down in Australia and New Zealand, I feel closer to you now, having seen the Southern Cross from the Dominican Republic, and it's kind of cool. It's kind of cool to see it there. A cool astronomical feature. All right, listen, something we got to talk about here, and it's a delicate subject, and that is, it's come up. There's been a bit of controversy. I don't want to go into the details, but the question is, what is homebrew? It has to do with the challenge that I presented rather flippantly to the guys from another podcast, and then expanded it and sent the same challenge to the entire SolderSmoke community. And it has to do with a little receiver that Dean and I were trying to get the local high school students to build. There it is. Dean is holding it up. It was called at the time the TJ DC RX. Now I guess we just call it the high school DC RX. It is
SolderSmoke DCRX.
SolderSmoke DCRX. We designed it to be as simple and as understandable as you could get. We really cut a lot of corners in an effort to bring it down to 4 boards that were really easy to build, that the students would be able to, quote, build themselves. That's the important part. Homebrew it, so that at least once in their lives, as they get prepared to move on into more high-tech areas, for at least once in their lives, they will have taken solder and a soldering iron and discrete components and built something that's really useful. And we decided that a direct conversion receiver would be just perfect for this. And we had high hopes, and anyway, we came close, but none of them actually finished it. So then we decided, okay, we're going to expand the challenge. Now we're going to go to another audience. We're going to talk to the people in this other podcast, and we're going to talk to the people in the SolderSmoke podcast, and we're going to encourage them to take up the challenge and build this thing. And everything seemed to be going pretty well. But then there was something that happened that really raises the question that I want to talk to you guys about today. We were talking to somebody from the other podcast, and it turns out that this person has sort of taken our design and turned it into a kit. He's going to do a kit of parts because he found that the parts acquisition was an onerous process and that would turn many people off. So he was going to come up with his selection of the kits, get the kits, put all the parts in the bag, and then send it to people. The other part that I found even more distressing was he didn't like the idea of us using 4 individual copper-clad boards on which to build the receiver. We very carefully thought about whether we should do Manhattan-style construction, whether we should use 4 individual boards, and we decided 4 individual boards with Manhattan-style construction would be about the best. The guy I'm talking about came back and said, no, he found the copper-clad boards to be dangerous, because when you clip them and you have to make little leads, little pads, you're clipping what he referred to as FR4 material. Pete, I follow your lead and I use SEM1, but there's fiberglass in there, and I suppose if you really sucked on it a lot, you could inhale some fiberglass dust. But I've never really seen this as a problem. Anyway, the decision, he decided to do away with the copper-clad boards that we were doing and offer as part of the kit a specially constructed board that he had made that would allow people just to go ahead and put the parts on the board and make that particular circuit or the entire radio, I'm not quite sure which, work. I kind of disliked this, and I was talking to Dean about this, and I said I disliked it because all through the process when we've been working on this receiver, multiple times we have had people come in and try to push Dean and I aside and say, oh no, you guys are doing it wrong. I would do it this way. I would build it this way. I would do the boards this way. I wouldn't use these parts, I'd use those parts. I wouldn't use this circuit, I would use that circuit. Why are you guys doing it this way? And our response has always been, okay, listen, if you want to do it differently, but we're recommending that you do it do it this way, which is sort of where we ended up. But this raises a question about what is homebrew and what is a kit building. Dean, you've been through this for a while, so what's your take on it? I think you've got a more magnanimous take on it than I do. I'm more of a radical fundamentalist home brewer, as I've said. I think Pete probably is too. But Dean, why don't you go ahead?
All right. So while I'm doing this, Bill, figure out how to turn on screen sharing because I want to share a picture here.
Let's see. I'm going to go to share here. Let's see. Share. No, it's just saying share. It says,
share should allow multiple participants.
let me see. Multiple participations can share simultaneously. There you go.
All right. So first thing, with regard to this, PCBs are dangerous. Let me just kind of show you what we're talking about because this is, because I think sometimes people don't actually understand what we mean. I mean, that's what we're talking about. So if this will kill you, so will getting struck by lightning, right? So I'm not too worried about it. Now you see on the right, I've got Rex's me pads there. If you're really worried about cutting up some PCBs, just grab some me pads and they snap right apart and they're ready to glue down. But
Yeah,
this is what we're talking about when we say Manhattan style construction.
And thanks for putting that up, Dean, because I was really flabbergasted when I heard that the copper-clad boards are dangerous. I mean, we're used to hearing other things are dangerous. We're used to hearing that the solder is dangerous, the solder fumes are dangerous, unleaded solder is dangerous, unleaded solder fumes are dangerous, the super glue is dangerous, the fumes from the super glue are dangerous, the voltage is dangerous, all this stuff. Antenna wires in the trees are dangerous. And we kind of dismissed that, but this is the first time I've ever heard that the copper-clad boards can.
All right, so set that aside. Now, I got started in this hobby because my dad was getting sick and he was a ham for his whole life, and I wanted to do something with him. And I got my license, and he gave me a Kenwood TS 450S, which I still have on the bench back there, and I enjoyed it. But I'm a software engineer. I've been a builder of things for my whole life, and I wanted to learn how to do stuff. And I read about this kit called MicroBitX. And I got really excited. I said, I'm going to build a MicroBitX. Well, I ordered the MicroBitX, and I was actually a little disappointed because a MicroBitX version 5 comes as a complete circuit board. All the components are already on the board. There is actually nothing to build except, put some connectors on it and put it in a box and, hook it up to power. And I built it and I got excited and it turned it on and I realized I learned absolutely nothing and didn't have any joy out of it. So I wanted to learn how to do stuff. And I talked to you guys and I built a Michigan Mighty Mite, and then I eventually built Pete's a simple SSB, and it's kind of gone from there. But I've also along the way I built a little tuner kit that I bought, the little automatic tuner. It's about a $50 kit you can get off eBay. I learned a bit building that, but none of it is as satisfying as building it yourself. I will say that some of the questions we're getting from the listeners are pretty similar to the kind of questions I had. I'm much more new at this than both of you, so I have a better recollection of what it is to know nothing. And when you know nothing, the first thing you believe is that every value on that schematic is carved in stone, that you cannot change anything. And you cannot get a 660 picofarad capacitor in that particular configuration. And why are there 330 picofarad capacitors on the schematic when it clearly says 660 picofarad? And it's like, if you don't know that you can parallel up or serialize components and make up values, if you don't know which components are critical, like the values in the oscillator are critical because they determine your frequency. Most of the other values, we're using 10% components in a lot of cases anyway, and they're not just not that critical. But my point is, you don't know that until you do something. When you buy a kit, you get a bag of parts and you plug, component A into slot A, component B into slot B. You're not going to learn that be forced to go through this process of thinking through how do I know what component I can use and what component I can't use, and how do I know when it's a problem and when it's not a problem. So there's just a difference in when you do it yourself, when you have selected every component, when you have soldered them on the board, you know what every component on that board does. You learn it as you go. And when you're doing it like we do, building one board at a time, you learn how an oscillator works. You learn how a mixer works. You learn how a filter works. You learn how to adjust the filter. Almost all that is gone when you work on kits. Now you can work on kits in a similar way where you force yourself to go through that process. But you got a schematic, you got an instruction manual, you got parts that are labeled, you got a board that's labeled. It's just not the same process as going through that. So for me, the process of building myself is just more satisfying. I learn more and I get more out of it.
Uh, yeah, I think good point, Steen. What do you think? What do you think, Pete?
Well, I was just imagining this whole board and something's gone wrong. Where do you start to fix it?
Yeah.
Where does it tell you in the kit? And a kit does not take you through the steps like you do with individual boards. And I always maintain build it in modules, and then you've isolated where a problem is. No audio output. So where do you look? The audio stage, and you can isolate that board. So I think all the things that Dean points out is that people want to jump from 0 to 100 and do it instantaneously. You can't. That's why you've always said, build the Michigan Mighty Mite, 7 parts. Learn from that. Learn how to solder. You learn how to different things work. So I guess I don't have the same view as that individual about approaching that. And I was going to, before Dean showed the me pads, I said, W1REX. I mean, if you're worried about it, they snap off.
Yeah.
Just glue them down.
That's it. I agree with both of you, and I
Hey,
think
hey,
that
Bill, before you go, let me just share one more screen
yeah,
because another thing that comes up is like parts are so hard to get. It's hard to source parts. And again, there are so many places that you can get parts now. The internet is amazing. I mean, here's just a couple of examples. By the way, for our little project, that little $5 pack of transistors that you get off of Amazon, it'll work just fine. You're gonna need four 2N3904 transistors. The J310s are a little harder to come by, but you can get those on Amazon too. Or if you really want to, go put your Mauser order together. And by the way, if you're going to build anything beyond this thing, you're going to use those 2N3904s over and over again. Buy 100 of them. They're a couple of cents a piece. You'll have them. You'll have them, and you're good to go. So parts are not hard to get, and particularly for this project. There is one part that is particular to this project that we recommend you do not buy on Amazon, and that is the audio transformer, because we found that the ones that are sold from China are not actually 1K to 8 ohm transformers. They're sold as that, but they don't work. So we both had tried them and they don't work. So I ended up buying those from Mauser, and so if you're gonna put a Mauser order together, we'll add some transistors, add a few capacitors, make it worth the $6 shipping, and you're
yeah,
good. So that's
yeah.
kind of my response to the parts are hard to get controversy.
And Pete and I also remember when parts were a lot harder to get. I mean, as a matter of fact, the first receiver that I ever tried to build and I failed was the Herring 85 in 1974, 75 in QST. It's probably 76. And one of the selling points on that receiver was that you could actually get all the parts to build it at the local Radio Shack. In other words, this was a time where if you couldn't get the parts at the local Radio Shack, you couldn't build it, right? Now, it's just a few clicks away from Amazon or Mauser or DigiKey, and boom, in a day or two, the stuff will be on your front porch. I mean, even with me here, I can make the same order, and it might take a couple of days longer, but it's still going to arrive here. So, it's as Pete has often said, this is a great time to be a home brewer, and parts acquisition is not a reason not to do it. I think that there is a difference in perspective in terms of the question about whether what something is homebrew or something is a kit. And I jokingly say that I'm kind of a radical fundamentalist home brewer, but I think this is the result kind of upbringing in ham radio. I come from a time when I used to look at QST magazine, especially the How's DX column. And Pete remembers, Pete looked at the same magazines. And you would see the pictures, especially from Eastern Europe, especially from the former Soviet Union. And there would be Vlad standing in front of the rig that he built himself. And it was completely homebrew. You could tell that he cut the panels. You could tell that he put the parts in there. He built that thing, and I always felt envious of those folks. Why, how come Vlad could do that and I never did? That was one of them. The other influence on me is Gene Shepard, and we talk about Gene Shepard a lot. But I grew up listening to Gene Shepard, and Shepard would talk about his problems with the rigs that he had as a kid. All of those rigs were homebrew, all of them. His famous story about the distortion that he was getting from his Heising modulator, he built that Heising modulator. Oh, sure, he looked at the ARRL handbook or somebody else to get the schematic. Heising didn't build it. He built it himself, but he homebrewed that modulator, and he was struggling with the problem of getting it going. So that for me was Gene Shepard was a home brewer, and I guess the latest example is a guy who has been a homebrew hero of mine for 20, 25 years now, and that's Frank Harris, K0IYE. Frank is probably a bit more radical fundamentalist than I am. I was looking at one of Frank's web pages. He's written the book From Crystals to Sideband, from crystal sets to sideband, which is a wonderful book. It's available online. I have links to it on the blog. But he even kind of criticizes folks who have retired from the electronics industry and then move into becoming the providers of kits and gizmos related to ham radio. And he says these guys are the ones that are kind of discouraging real home brewing. Like I said, that's kind of a radical position, but Frank's got a point there, and I think it's an interesting thing. I remember the picture of Frank Harris's homebrew station that I saw. I first saw it in World Radio, that little pulp magazine that used to come out, and there was a picture of Frank's station. And I said, "My God, I want to build a station like that." So yeah, I think there's a big difference between kits and homebrew. So for example, when I look at the operating table here in front of me, I have the 1510 rig. It is completely homebrew. I mean, there's not a circuit in there that I didn't build myself. There's not even a chip. There's not even a regulator chip. There's Zener diodes where I needed regulators. The Mythbuster rig here, I think I always view it as less homebrew because it's got the Yaesu FT101 VFO in there, the one that Pete has been encouraging us to buy and that you have started to buy, Dean. It's in there. I didn't build that one. It's also got a PLJ frequency counter in there. I didn't build that one either. And I even use an LM386 audio amplifier in there. I didn't build the LM386. It also uses little tiny boards, TIA boards, that Todd out there in Portland, K7TFC, and mostly DIY RF has provided.
I have a question for you, Bill.
Yeah.
Did you wind your own electrolytic capacitors and fill them with, oil?
No, well, I think that gets to another point. We do get criticism. People say, "Oh, well, you guys buy the transistors." Yeah, okay, we buy the transistors. People buy tubes. People bought the tubes. Very few people blew their own glass tubes. So
Colpitts invented the oscillator we use.
All right,
No,
that's it.
We didn't design it from scratch.
Well,
but what we do though is we do engineering. We didn't start with somebody else's complete design for this radio. We designed this radio board by board. Bill and I went painstakingly through board by board. We built dozens of revisions of each board until we were satisfied that we had something that we could build. So yeah, we built this radio. We designed it. We built it. We used lots of other prior art, as everybody does, but we definitely built it. I'll also say, Bill, there are differences in the kits that are out there as well. So if you get a kit from Hans G0 UPL, His kits come with very detailed instructions. They come with descriptions of how the circuit works. They come with instructions for how to test it. You will learn if you build one of Hans' kits and follow what he tells you to. They show you what the traces look like on the filters. So yeah, you will learn if you build from kits like that. But what I encourage you to do is learn, right? Because that's, for me at least, that is what the pleasure in all this is. It's learning and getting better at this sort of thing. I can go to IKEA and put together a table. I won't learn anything about carpentry. So
Yeah, I know. I'm reaching up here because I have the QMX here. Look, that a buddy of mine had given me. Here's the QMX, okay?
yeah,
And I used it on straight key night. It was great. It was great fun. But it's not a homebrew rig. It's not. And even if I assembled it, I would have assembled a kit. And it gets back to something I said about Heath kits. We grew up in the age of Heath kits. Nobody finished a Heath kit HW101, sat back and looked at it and said, "Look, Ma, I homebrewed a radio." Home brewing was something different. It was just different. It was qualitatively different. And that's what I was saying here. When I look at my operating table, I have the 1510 rig, which is completely homebrew, and it looks it. And I can't show you here, but you guys have seen pictures of it. It's in a wooden box. It's got a weird kind of vernier dial on it. It's got holes that I just cut through the wood with a circular saw. It really is it looks homebrew, and it is homebrew. Now, right next to it, I have an amplifier. I have the AN762 amplifier from Communications Concepts. It is a kit. I built it from a kit. I never refer to that as a homebrew amplifier. Okay, I built it. I assembled the kit. However, it is an assembled kit. All right. So I'm clear about that. A little bit further down on the same operating table, I have the box filled with low pass filters that Pete told me to buy. They come from a Ten-Tech Delta. I don't even think that's a kit. All I did is I put them in the box. So that's the Ten-Tech Delta low pass filters. And then right next to it, I have the Samlex power supply, switching power supply, that is a completely commercial product. And I recognize that it's a completely commercial product. So it's when I look down the table, I see homebrew, kit built, commercial stuff, right? And it's all there. But I don't kind of kid myself and say, well, that kit, it's the same as a homebrew. It's just not. But this gets to another question, and this is something I wanted to ask about. And Dean talked about this a little bit. Designing it. A lot of times when you're on the air with a homebrew rig, you'll tell the other guy, "Hey, rig here's homebrew, 100 watts to a dipole." The question comes back very often. Yeah, but did you design it yourself?
well, the first question is, well, what kit did you use?
And
Because
then the second,
they can't
right.
even conceive that you didn't build it from a kit.
Right. And then I'm always kind of annoyed by this business about did you design it yourself? Because it indicates that the person, first of all, it indicates that the person who's asking the question never really actually built something or homebrewed something themselves. If they did, for example, if they had built a superhet receiver, who invented the superhet receiver? Howard Armstrong invented the superhet receiver in
December the
France.
18th.
In
December the
France.
18th.
Yeah,
December the 18th.
yeah. And he just sat there and he was looking at a German bomber flying over Paris, and the idea for a superhet came to him. So if you're building a superhet receiver, even if you heroically sit there with a blank piece of paper and a pencil at the start, and you come up with a superhet, sorry, buddy, somebody else did it. Dean mentioned the oscillators. Is there a Colpitts oscillator in there? Is there a Hartley? Is there a Pierce? Right? Even a Franklin, right? Those guys, they were all invented by the guys we just named, right? And people just use those circuits. The diode ring mixer. Are you going to come up with on your own a diode ring mixer, or are you just going to take one?
I also have started restoring some old radios, and I discovered this thing called the All-American 5. And it turns out there were dozens and dozens and dozens of manufacturers that made essentially the same AM radio.
I have
Five
one sitting
tubes,
here.
same circuit.
The S38 that I have sitting on the shelf here is
And they all had
basically
engineers working for them whose job was to design that radio, but they all used basically the same. There are slight differences. They made engineering choices, they made layout choices. But yeah, so this is a red herring. Did you design it? I mean, nobody designs everything right from scratch. We do lots of engineering along the way. I want to kind of wrap this by just saying, look, folks, we are not saying kit building bad, homebrew good. We're saying if you want to build kits, build kits. But if you homebrew, you're going to learn more than you would otherwise. And, our preference is homebrew for the kinds of radios that we build. That's our preference, right? And for all the reasons we've just talked about. And I think Farhan really says it best. When you have built that receiver, and you've spent your day at the lab placing part in the bench, placing parts, and then you turn it on and it starts breathing in RF, the sense of satisfaction you get is frankly unlike anything I would have ever gotten from a kit. Like I said, I put the microbitics together and I enjoyed it, but I didn't get that sense of satisfaction like, all right, I have actually done something.
Yeah, because I was thinking about this during the last few days, and I put up a rather long article about the first superhet receiver that I built, and it was the Barbados receiver designed by Doug DeMaw, and I wrote the article probably 1997 or something like that. And I built the thing in the Dominican Republic in 1990. No, I built it after the Dominican Republic. I built it in Northern Virginia. I built the transmitter in the Dominican Republic, but then I felt guilty about using the transmitter with a commercial receiver with my Drake 2B. So I went ahead and built this receiver. And then I felt bad about using a power supply that I had bought. So I built the power supply. Then I felt bad about using a side tone monitor, the Drake 2B. So I built another site. Anyway, at the end of the whole process, the whole thing was homebrew. But the article talks about all of the trials and tribulations that I went through in getting to this point where I could say, yeah, this thing is homebrew, right? And the satisfaction that came with all the little modifications, all the little component choices, all the little design applications that I had to go through to get this thing to work like a real receiver. I think if I had gone a different route, I might have missed all that. And so, yeah, homebrew. Anyway, thanks, guys. Thanks for your thoughts on that.
So before we kind of leave this segment, I promised everybody that I am going to be doing an update for each of the boards. You've seen some of the pictures from the intro video that I'm polishing. In the next couple of days, I'll have the intro video for kind of step one for anybody that wants to build along with us. I will also say, and Bill will probably get to this in Mailbag, we got a lot of you that are out there building it already, and some with great success, some with less success. If you're struggling, just hang on. I'll step you through it. I've created a SolderSmoke Discord server with a channel just for the direct conversion receiver. When I put out the first video, I will include the invitation to the Discord server so that if you want to build along with me, I'm going to rebuild this from board by board here over the next month and take you through every decision along the way and all those questions about how do you do the board layout, what components are important, what components you can relax a little bit on. I'll cover that as we go through each of the boards.
All right, good. Thanks, Jan. Everybody looking forward to that. And we've got some. There are a number of people who've been building it successfully. We'll talk about them in the mailbag. That's a good sign. That's a good sign. It's a sign that it is possible to do this. Also, it's a good sign that folks have had trouble because that's an indication that it's difficult. It's not just pick and place stuff on a board, stuff like that. Anyway, it's my turn to talk about the bench. I take that turn because I'm sitting in SolderSmoke Shack South. And so I'll just go through it kind of quickly. I already mentioned straight Keynight with the QMX given to me by my friend Bob. Thanks, Bob. Thanks for the QMX. It worked great. I worked 3 stations before the sunspots hit on straight Keynight. Anyway, that was good. And I mentioned the AN762 0.1 kilowatt amplifier that I have here. And I assembled the kit. And the only thing I really had to do was Socketry, which was George Dobbs' term, Socketry, and relays and a heat sink. And so I put them on the box, and now I have this thing here. And I must say, it works fine. I'm getting 100 watts out, 120 watts out on a whole bunch of different bands. And I'm using the Ten-Tech Delta low-pass filters that Pete recommended that I buy. I have them in a separate box. And all I have to do is remember to change the low pass filter when I change bands, or else things don't work very well. If you're transmitting on 20 or on 10 with a 20-meter low pass filter, it's not too good. I want to share a tale of woe that I've had here, because people like it when we talk about tales of woe. And the tale of woe that I'm talking about here has to do with the homebrew rig that I mentioned earlier. It's the 1510 rig. I built this rig. This was 1510 version 1. I built version 2, but I left that up in Northern Virginia. This one, 1510 version 1, I brought down here because it has a tuning dial on the front that was given to me by Hotel India 8 Papa. Pericles, my Pericles Perdomo, is a silent key now. But it seemed fitting that I would bring this thing back to the Dominican Republic with me, and it is here now. Now, here's the trouble that cropped up. I'd be working with this thing, and I'd be thinking, man, this is great. Everything's going good. 10 meters sounds terrific. And all of a sudden, I would hear whoop, an oscillation in the background. So my first thought, assumption, I don't test. I just assume, oh, this must be the stupid little simple AF amplifier that I pulled out of one of the TJ DCRX high school receivers and put it in there because I like the sound of it. It must be oscillating. So I didn't do any tests. I just sort of focused on that stage. That was a mistake. I should have, in the beginning, just tried to isolate the stage that was causing the trouble, because in the end it turned out that it was not the audio amplifier stage. It was a different stage. I wasted a lot of time focused on that audio amplifier stage, trying to fix problems that were not there. It was not oscillating. There was not a lack of bypass capacitance. It wasn't that the speaker was too close to the input. It wasn't the Barkhausen criteria. It wasn't any of that stuff. It wasn't even in the audio stage. The problem really became apparent to me when I started looking at the output from the carrier oscillator and the BFO. And this is one of the problems that's most difficult to solve is an intermittent problem, because it's not there all the time. And to fix it, it has to be occurring. And if it occurs only intermittently, you have to be patient and wait for it to occur, and then quickly do some troubleshooting to find out what's going wrong. And then usually before you finish the troubleshooting, boop, the problem disappears and you're back at square one. This case,
or when it's Manhattan Pad, you take a pencil with a rubber eraser and you touch every part until the
right.
problem comes up.
To see which one you didn't solder in properly, right? It wasn't like that. I did that. I did that a couple times. I went through the soldering iron and made sure everything was soldered in well. Nope, that wasn't it. The problem, I was looking at the output from the carrier oscillator and the BFO, and I'm looking at it on the Regal scope that I have here. And all of a sudden, I notice that the waveform on the scope looks kind of fuzzy. It looks kind of weird. It looks like there's another signal in there. But sometimes that could be just because of the way you've got the scope set up, or the way you've got the test probe placed, or anything else. So sometimes it doesn't mean anything. However, in this case, I'm looking at it and I'm listening to the sound, and I notice as soon as the signal becomes unfuzzy, as soon as it becomes a sharp sine wave form on the screen, the whooping sound goes away. Uh-oh, that's a big hint right there. So I started checking, and I started checking the carrier oscillator, the BFO, and I discovered that I had really cut some corners when I put this thing in there. I started with the circuit from Farhan's BitX20, and I just sort of decided to use that one. But Farhan and the BitX20, the oscillator was running, I think, down around 5 megahertz or something like that, maybe 10 megahertz. This thing, the oscillator was running at 24.9, significantly higher. So I needed to have more amplification from the oscillators just to get up to the 7 dBm point that I needed to drive the mixer, the singly balanced mixer that I was going to use. Again, taking it from Farhan's BitX20. So I very, very hastily just slapped another 2N3904 in there, put in what I thought was like a common emitter amplifier, didn't pay any much attention to matching and anything else. I thought, oh, okay, it looks like it's getting close to 7 dBm. I just left it at that. And that's what was causing the trouble. The amplifier was not well designed, and it was creating all kinds of feedback, and it was just creating all kinds of mismatches and opportunities. So I kind of messed around with the circuit for a while, and then I got tired of it, and I just said, this gets back to the nightmare that the Dean and I have had, where you just end up taking all the parts off the board, and you end up with a big pile of like messed up parts and an empty board. But that's what I did on a smaller scale with the board that I had for the mixer and the oscillators. And then I completely rebuilt it, but I was careful this time. I used LTSpice to design the final amplifier, and I built it stage by stage, and I tested each stage. I built the oscillator, first the oscillator stage, the crystal oscillator. Is it okay? Is it producing the right amount of output? Then I built one that was an emitter follower that was really just a buffer. Then I built the amplifier stage, again, using LTSpice. And then I built the mixer stage, which is kind of a tri-filler transformer with two diodes, a singly balanced a singly balanced mixer. I built that, and Bob was my uncle. So I think the lesson there is don't jump to any conclusions about which stage is causing you the trouble, and be patient when you're dealing with an intermittent problem. Anyway, that's what I have on that one. Any questions on that tale of woe? The whooping is gone.
I wanted to add a little postscript to that, Bill. When I built shortly after Farhan released the design, like a couple weeks, I built a BitX 20. And instead of putting, I put sockets everywhere. Every stage had a socket, so I could run different transistors through there. And I found that that was such a robust design. You could put any kind of NPN transistor in a socket and it would work, except for one area, the BFO. The BFO was sensitive, so not all transistors worked in that BFO circuit. Most of them did, but a lot didn't. As a matter of fact, I had a bag of 2N706s, which was predates the 2N3904. It worked in any place except the BFO. So if you replicated that BFO, some transistors, and it may be also an issue with the transistors that you had in there, could affect that output. So I mean, when you said that, I said, "Man, I've been there."
That could be it. Dean and I faced a similar problem when we were doing the audio
Yeah.
frequency amplifier on the direct conversion receiver. We just happened to use two N3904s that happened to have basically low HFE, low gain, low DC gain. And then somebody else, Mike from the Radio Club, built one, and he happened to use transistors that had a much higher gain. We weren't using any feedback circuits, so it was not beta independent. It was very beta dependent. And his amplifiers kind of took off and oscillated a lot. And we kind of scratched our heads to try to figure out what the difference was. And the difference was that there's a lot of variation in gain, even among the same batch of two N3904s.
All right, I'm holding up the receiver again, and this is the audio board, and this is the power rail up here. And you can see, look at that row of capacitors on the board. That's because these transistors tend to run away, and I kept adding bypass on the DC line until the oscillation went away. So this is the kind of stuff Pete always says, if you know stuff, you can do stuff. This is the kind of stuff you learn as you're building stuff manually. It's like, all right, what the heck is wrong with this? Where can you go with it? So yeah,
That's a good example. Yeah, you got to try to figure out, why are you doing this? Why is it taking off? And
and by the way, all those caps are not on the schematic.
but why not? They should be on the schematic. Anyway, one final point on this. When I got the thing working and the whooping sound went away, but then I tested the output from the final transistor there, and I was hoping that it was going to be at 7 dBm across. I do it as Wes recommends, and I take a 50 ohm resistor and put it across the output, and then I measure it. Am I getting 7 dBm across a 50 ohm resistor? You can't do it across the diodes because you get a kind of a goofy waveform because the diodes conduct. And it was not quite 7 dBm. It was not quite. It was a little bit below. It was like 5 dBm. But I still found that it was enough to turn on and turn off the diodes, which was the most important thing. And so the mixing was occurring. And not only that, it wasn't like there was an SBL1 that has a pretty rigid specification that to get it to work at optimal levels you have to have 7 dBm. This was much more of a kind of just two diodes and a tri-filler transformer in there. I remember when Farhan was talking about the tri-filler transformers, he said, put in about 10 turns tri-filler. But it could have been 11, could have been 9. And so it seemed to work. If anybody thinks there's a real problem with me running this mixer at 5 dBm instead of 7 dBm, let us know. What do you think, Pete? Is it okay?
It's okay.
Right.
Okay.
It's not whooping. It's not going whoop.
What you may find is if you don't have enough drive, especially like as a product detector, DBM as a product detector, you may have a little lower audio output. If you get it to 7 dBm, you'll get the full audio output. You'll see it there, but it's not going to make that much difference.
All right, thanks. Thanks. Yeah, I think the audio output is fine with this thing. Hey, one thing I want to mention, you see blinking over here. People who are looking at the screen in the video portion, you can see a little light going on and off there. This is the beacon that I set up. I have a 10-meter beacon. The frequency it's between 28233 and 28234. We're somewhere in there. Tune around a little bit. And if you hear my beacon, please send me an email. Tell me you heard it. Dean was the first one to hear it. Dean is sharing his screen. There it is. Look at that. Look at that. You could actually see it down there at the bottom. N2CQR beacon and then N2CQR at. Mike, WN2A, actually sent me the PIC controller that I'm using to create the CW. The transmitter itself is a little slugger designed by Doug DeMaw that I built probably 25 years ago. It's been sitting in my junk box ever since. And for some reason, when I came down here this time, I decided, I'll throw that in the box. I pulled it out of the junk box in Virginia, threw it there. And as soon as I got down here, Mike sent me a message saying, hey, why don't you do a beacon? I said, great, send me the controller. He sent me the controller, and this created pressure. And so this is 3 watts to a quarter wave vertical out on my terrace. And the very first station to hear it and to copy it and to make a recording of it is Dean up there in Northern Virginia. And he used a homebrew SBitX. You're looking at the screen from his homebrew SBitX. So this was an experience. It was just so sweet at so many different levels. And then I think Pete tried to listen for it and thinks he heard it. Mike in New Jersey, who sent me the controller, he heard it. And get this, through the reverse beacon network, there are stations that will pick up beacons, not just CQs, beacons. And there's a station in Germany that has repeatedly picked up my signal from the beacon. I could see him. It's frequently being picked up by a station. And there's another station in Warrenton, Virginia, K1RA. He's in Warrenton, Virginia, which is close to where Dean and I live.
Yep.
And he's been repeatedly picking it up also. So it's kind of fun. I used a lot of junk that I had laying around. I had an old power supply. I had a PLJ frequency counter, little SWR meter. It's fun to see the lights blinking and the and the meter jumping. But 3 watts, 10 meters. Yeah.
I had great satisfaction just listening to it. And I don't know CW. I don't do CW, but thank you, Bill, for having CQ in your call sign, because that's something I actually do recognize. So
there you go.
So
CQR. There you go.
CQR is something I actually can I can copy. And so I heard the CQ and I thought, that must be Bill, right? So but Farhan has done a nice thing in the SBitX software in that he's put the decoder on there, and if you get the words per minute set about right, you can see it decodes. So
I learned from the reverse beacon network that Mike has sent a coder that is at 17 or 18 words per minute. So it's a little faster than I thought. I thought it might have been 14 just from listening to it, but it's 17 or 18. So that might help a little bit.
So if you're still beaconing, I'll turn it up to 18 and see if I even get a better decode. But
I'm
it
I'm
was so much fun. First, I could kind of hear the signal. Oh, by the way, we got into another one of these conversations about where do I set the dial frequency? If you're at 228.234.6, where do I set the dial frequency on the SBitX? And you can see on the upper left, I'm in CW mode, but my dial frequency is 28.234, but he's transmitting on 28.234.5 or 4 or something like that. So this debate about, well, should the dial frequency represent the transmitted frequency or the frequency I have to be on to receive it? Because because if I tune right to that point, it's going to zero beat. I won't hear him. So,
That's right.
so it's just and there's the raging debate on the internet forums about where the dial frequency should be set.
Fortunately, we're sideband guys, and so
Yeah.
But anyway, that was fun. Anyway, the last thing I have on my list is antenna thoughts. I'm still thinking about what antenna I'm going to put up out there. And I noticed that Amazon's selling tripods. I kind of like the idea of taking an antenna out on the terrace, setting it up, and then when we leave, just take the whole thing down, put it in storage, and set it up again. I'm not crazy about the idea of crawling up on the roof, going up 8 or 10 feet. No, don't want to do that anymore. So I might buy one of these tripods from Amazon. Anyway, that's what I have. Hey, listen, it's almost time for SolderSmoke Mailbag. I mean, no, not Mailbag. Pete, what time is it for?
Shameless Commerce Division.
Shameless Commerce Division. Okay, the things that we got to mention about Shameless Commerce, mostly DIY RF. There are lots of useful boards and kits. We've been bad-mouthing boards and kits and gizmos here, but don't take that to heart. I have used many of the TIA boards, even in the Mythbuster rig here. Scott K7 TFC is clearly one of us. He's got a very fine business store. Check it out. You could reach his website through the soldersmoke.blogspot.com page. Become a SolderSmoke patron. This is a lot of people have been signing up as patrons, and they come into the system as patron through the Patreon system. We need your help. We're one of the only sites, blogs, or podcasts that are defending really homebrew in the way that we discussed it today. So you could support us. We do have costs. Things are costly. Zoom costs money. The website server costs money. So join us. Become a patron, a Patreon, and I do try to send some special content to the Patreon patrons. Finally, buy stuff from Amazon and eBay using the links at our sites. Anyway, that's what I have. Let's see, Dean, you're up. What's on your bench?
All right. So I want to ask you. I'm loving the fact that we're on Zoom and that we're doing these things video and audio. So if you're not listening, if you listen to the audio, go to the YouTube channel and watch the video because we're starting to share some interesting content. So what do we got here, guys?
Oh, I love it. Oh, I love it. Yeah, that's I feel close to that machine. So does Pete.
So it's a Yaesu VFO. With a little bit of help from Bill, I extended the wires out. The OM that took this apart was very nice, that he actually put a little tape on the back, and he said, the yellow wire is the output, the red wire is the power, the blue wire is the clarifier. So it's like, all right, I know what to hook up to there. Thing fired up right up, but I learned something along the way. You'll notice that the oscilloscope probe is not grounded. And the power supply that I'm using is the Homebrew linear power supply that I built a couple of years ago. And the reason it's not grounded is I have a ground loop in that power supply that goes back to safety ground, basically, that's not supposed to be there in the power supply. Power supply should be completely, the DC side of the power supply should be completely isolated from the AC side of the power supply. So I actually have a design problem in that, and it made itself evident when I had it hooked up, and those black wires started getting hot. It's like, no, there should not be current going through those things. So I disconnected it, and it works just fine. I put it on my commercial benchtop power supply, works just fine. But I learned something in testing this out. So I'm gonna build a rig around this sort of thing, probably a 20 meter single band 20 meter SSB rig. But that'll be kind of next up on my bench. And this is the unit you sent out the eBay link on, Pete. It came with a nice
Yeah.
windows for the actual dials. So and it works perfectly. So I had to clean up the gears a little bit to get it to turn, but other than that, it just fired right up. So
Pete
that's
is
about the only. Go ahead.
Pete has been pushing these things with great success for a long time. I own about 6 of them. 2 of them in a rig. I even sent one back to India with Farhan. Now Dean's got one.
This was a steal, $35. Now most of them are going for like $70. So, but you gotta be patient. They'll show up. Second thing is I also mentioned, I'm the chair of the Vienna Wireless Society Makers Group, and we have started our software design receiver front end project. And it's not on the SolderSmoke YouTube channel, but if you go to the Vienna Wireless Society YouTube channel and go to the Makers channel on there, our first meeting for the SDR receivers up there, and Oliver, KI3P, went through the schematic design. And we're actually going to do what I just said I don't like doing. We're going to build the schematic in KiCad. We're going to lay it out on a PCB. We're going to send the PCB Gerber files off to China, get boards back. Then we're going to have an assembly day and we're going to stuff boards, because for me, this is another learning experience. And for the members of our club, it's another learning experience. And we're actually going to use surface mount parts, but we're going to use 1206, which are big enough that you can solder by hand. I'm getting criticism from some of our more experienced builders that I'm not requiring everybody to get hot air surface mount rework stations, that we shouldn't be using those big parts. They're just as big as through-hole parts. And I'm just trying to remind them, we're trying to do this easy. We're trying to bring people into the fold. We're not trying to scare people off. I don't want to send people off for this, because we have 350 members of the Vienna Wireless Society. We got about 10 that are active in the maker group, and I'm trying to expand that to maybe 15. So, so, but we had 25 people on our intro Zoom call. There's a GitHub out there. Again, if you go to the Vienna Wireless Society YouTube page, you can find that. And then the last thing is, it's not building anything. Let me move out of the way here. So you kind of see your way back into my shack. The first thing you see here is the Homebrew S-Bit-X. Off to the side right here, that's a Hammerland HQ170 Alpha. This was the receiver that I grew up listening to at my dad's house. And so I bought one of those and restored it, got it working, and then I got all my commercial gear and my other stuff back on the. So my shack is actually looking really neat right now, because I hosted 4 or 5 families here on ARL Kids Day, and it was quite fun. We had kids from well, the oldest was a 17-year-old, Micah, who's a member of our club. He was great because he's a AE already. He's an extra. And then we had kids down to as young as 6 or 7 years old, and they all got on the air, and the exchange was your name, your age, and your favorite color. And it was great talking to some of the OMs out there, because they'd get on and say, well, I'm Al. I'm 78. My favorite color is green. And they were so good working with the kids. I mean, there are, as you know, what we call lids out on the bands, but there are also wonderful people out on the bands, and they were so gracious and delightful. And one OM talked to every one of the 7 or 8 kids in our group, got them all talking on the radio. Even the mic shy ones, he got talking, and that was just a real pleasure hosting ARL Kids Day. So that's it from SolderSmoke, Virginia. The only SolderSmoke Virginia until Bill gets back.
That's right. Over to California.
Hey guys, good morning and happy New Year. Just a couple of things here. First I had an interesting experience with my one of my websites. My one of my primary websites that's more of an archive is jessystems.com. And I've had that for a long time, and there's a lot of old projects on there. And I got a note from one of my blog readers says you better check that site. And all of a sudden, I found out the site was no longer secure. And when you did an internet search, it gives you jessystems.com. It kind of gives you a capsule form. The metadata that you can put in there kind of tells you what it is. And the heading was sex, drugs, and loose women. Someone took over that site, and it was the fault of GoDaddy because in December I had re-upped the SSL certificate, and somehow they let it drop. So there was a period of a couple of weeks in there where someone took over that site, and that's what the heading. So I removed the index page, and they got it fixed. They got it back online. So now, when you do a search on JES systems, you no longer see sex, drugs, and loose women. So it's all about project. But I mean, I paid $300 for that SSL certificate, and somehow they let it fall through the cracks. So if you go to the jessystems.com, you'll find that it's a little different index page because I removed anything that may be embedded in the metadata, so that you don't get that heading anymore. But there are a couple of projects on there. There are a couple of CW transceivers. There are two CW transceivers on that page, and they're kind of interesting. One uses mimic devices, and that's why in the background here is a CW transmitter. It's kind of cool. I didn't build this, but I spotted this picture, and I said that's what a station like that I had in the early days when I was on the air. It was something homebrew. Had like a 6L6 in the output, so you get maybe 15, 20 watts, and it made a lot of contacts with it. So it was really a lot of fun. And also on that page, JES Systems, is how I built a solid state version of the Heathkit HW100. So you might find some interest in that. Now, when we were talking about homebrew versus kits, here's a picture of the work I've been progressing on the tube final for the hybrid rig. So it's got the 12DQ7 and it's 12GE5. Unfortunately, 4.5 days with the power off doesn't give you much chance to do any soldering work. But this is true homebrew, and it's got some unique features right here. You can't see a lot of the detail. Is a bandpass coupler, and then on the output stage, I have a separate board already built with the W3NQN. So I hope to get some time to get some work on that and get that on the air. And then finally, we'll have almost an all-tube rig. Another little device I wanted to share with you because the power was out is this here is a 200-watt inverter, 12 volts to 110 volts. And it cost about $15, and this might be worth the investment. I know, Bill, you got a 1 kW, but this one could you put right across your battery of your car, and it'll do 400 watts peak, 200 watts constant. This also has a USB port on it, so you can sort of charge phones, but the current level is only like a half an amp, so you're not. It's going to take you a year to charge some phones, but it does have a standard 110 volt outlet on it. So you can put this across the battery in the car, plug in the charger in there, and in about an hour you can fully charge a phone or charge your laptop. So lots of people here went out because of what's happened. It's twice in 2 months we've had our power out, and you got to be careful about doing something rash in the heat of the moment. Two of my neighbors went out the first time the power went out, and they bought some emergency power systems. And the guy next door bought a solar system and a battery, and he's got the inverter, and I think he spent $1,200. And he found out that this one day in the sun is not enough to charge the battery. Now, if you look at some of the specs, the efficiency of those solar panels is like 22% is a good one. So he he was not getting the battery fully charged during the day. So what he had to do is take the battery down to where his wife works late in the afternoon, have the battery charged up so he could get 4 or 5 hours of TV, at least run the refrigerator, keep things cool. So be careful what you do. And then another neighbor went out to Harbor Freight and bought a 1500-watt generator. And he found that he could power his refrigerator and the TV set. So then he thought he'd make some coffee, and he discovered that he stalled the generator. So he has a choice. He can either make a pot of coffee or he can run the TV set and the computer. And the problem is the 1500 watts that is advertised is a peak turn on demand. The average output of that thing is only like 800 watts. So be careful when you buy these systems that you look at constant output versus a peak load. So he says, "Gee, I'm going to have to buy another generator now." So, yeah, in the heat of the moment, you want to do something. You're without power for a couple of days, and you sure miss having the TV on or being able to, light off the microwave. So it's really, really be careful if you're going to buy some of this stuff. But I mean, you need to engineer Dean's term. You need to engineer a system versus what you're doing, at least understanding what it takes. For instance, there's some nice 2 kW inverters that are reasonably priced, even some nice 3 or 4 kW. But you got to remember one thing. If you get one of these 100 amp batteries, you take 12 times 100, that's 1 kW. So if you have a 4 kW inverter, you better have 4 batteries that you're feeding that. Otherwise, you can never get up to the load, the rated load. So, take a little time to look at that. So not a lot doing, dramatically impacted by the power outage, but I hope to get working on the rig there and finish that up. I'm kind of excited to get that thing working. I mean, it's working fine now at 6 watts, but I really would like to get about 20 watts input. So hopefully by the time we have a next podcast, I'll be able to share what I've got to do. But totally homebrew. I laid the circuit out. This is not a kit. I had to do the engineering to figure out how it's going to all go together, where the pad should go, and what have you. So this is what you can do with homebrew. You want something, you can, rather than try to find something in the catalog, you can do it all yourself. But it takes a little time, and this is where LTSpice comes in, other simulation programs, and using some tools available to you. And I will say that when I run the CNC, I use a mask so that I protect myself from the little fine dust that's generated, and I have a vacuum system on my CNC to clean up as we go along, and ear protection too, because it really, some of the things churning away at 30,000 RPM on the drill head. You can impact your hearing, but these are safety precautions that you take, and if you do that, it's okay to work with it. So I'm always careful to make sure I got the mask on, I got the ear protection, and eye protection too, because one of the cutting heads could break off, and that thing flies through the air and it hits you in the eye. So, but anyway, that's what's going on here at the N6QW Shack. So back to you, Bill.
Well, I got a question for you, Pete. Did you take advantage of the low RF noise environment that you're in when the power's out for 3 days?
Well, no, because I'm missing one thing, which I fixed. I got a gift card from Amazon, so I've got a 12-volt, 10 amp battery coming with a charger. So this way it'll run a QRP rig. I'm not
Awesome.
interested in powering the whole house, but I got something coming. It'll be here next week. So yes, I'll be able to do that next time.
Will it be a QRP CW rig?
No,
There you go.
I'm going to use my KWM-4.
There
By
you
the
go.
way, that is a rig I designed and engineered. That's not a kit, and it was probably one of the most extensive projects I've ever done. But that's total Pete design. I had to learn to integrate the mechanical filter into the design. Most of these mechanical filters were in tube rigs, not solid state rigs. Although the SBE33 did that, and I had to engineer that. So that is totally a homebrew rig. And when I get asked, did you make that yourself? Yes. Did you design it? Yes.
Okay. All right. Thanks, Pete. All right, now this brings us to the mailbag. Speaking of nice homebrew radios, we saw a picture posted by Dave Newkirk, who's currently got the call sign W9BRD. He is the son of Rod Newkirk, who used to write the How's DX column that I used to see the pictures of Vlad and the other Eastern Europeans in. He's got some great comments on homebrew radio and a great picture of all of the rigs that he's built out of like coffee cans. Good stuff. Derek N9TD. Derek built the direct conversion receiver. Fine business, Derek. Derek keeps asking us questions, and I remember that we were congratulating Derek about overcoming his double E tendencies to make the perfect the enemy of the good enough, and he should continue to do that. Keep it up, Derek. Realize that there are many imperfections in the direct conversion receiver. We're aware of them, but we wanted to keep it simple. All right, so. Anyway, that was what was behind that. But congratulations on building that. We got a nice message from Peter VK2EMU. He reminds us that it's now summertime in Australia, and it was 39 degrees C there, 39 centigrade. That's quite hot. Yeah. Drew, November 7 Delta Alpha. He sent us some great comments on kits versus homebrew. And I think he's in general agreement with what we said about what is a kit and what is homebrew. Tommy, SA2, Charlie Lima Charlie. Tommy's really interesting guy. He's very interested in old military radio gear, but he has a lot of old test gear too. And he's been working on his Hewlett-Packard 8640. I have one of these too, the HP 8640B signal generator. Tommy actually went in and fixed the cavity resonator.
Ooh.
A cavity resonator on that thing. All I could say, as they say these days, respect. All right, that was not for the faint of heart. Ben, KC9DLM, sent a good presentation from India, and we have the link up there on the SolderSmoke page. Scott, KQ4 AOP, and Derek, who we mentioned earlier, N9TD, are offering to 3D print the PTO coil forms. On the high school direct conversion receiver, there's one part that really calls for kind of 3D printing. I don't have a 3D printer, and I wouldn't know how to use one if I did. So I turned to Dean. Dean gave them to me, and then Scott and Derek are offering similar services. So if there's anybody out there who wants to build this receiver but is hesitant to do so because they don't have the 3D printer or the skills to print one, contact Scott or Derek, and they will provide. They will. I think they will stick them in the mail for you too, and you'll end up with the coil form that you need to make the PTO for this receiver. Donnie WA9TGT. He sent us a real nice picture. I think Pete, he sent them to you of the direct conversion receiver, 40 meters, and the
Transmitter.
And the transmitter. Now, this is a good example of what Dean was talking about, because I think he started out by building them from kits. When he built them from kits, he discovered that a lot of his kind of negative perceptions of direct conversion receivers were incorrect. So he decided that he wants to build one, and he wants to build one on his own. He wants to homebrew one, which I think is where the high school receiver project could come in quite handy for Donnie. Thanks for sending that to us, Donnie. Chuck, Kilo Echo 5, Hotel Papa Yankee, sent us some there you go. Look at that. Those Dean's got some pictures up of the 3D printed forms. Very good.
Yeah, so if you have, this is a $100 printer. If you have a $100 printer, they print really. I printed 4 of them yesterday in about an hour. Well, it takes about 4 or 5 hours to print, but you level the bed, fire it, and go. So there they are. Those are the PTO forms.
There you go. We got thank you, Dean. We got a nice email from Chuck KE5HPY, and he built a direct conversion receiver back a few years ago when it was in vogue to put everything inside an Altoids tin. And he's got the entire DC receiver inside the Altoids tin. I've got pictures of it up on the SolderSmoke blog. It's really good because even if you look at the Altoids tin, you could see the 4 stages that we built when we built the high school direct conversion receiver, and he's been very pleased with it. Todd, Victor Echo 7, Bravo Papa Oscar, a very familiar call. This is Todd. It's also Vasily. Anyway, has resurrected an old website called Popcorn Electronics, and his first video came out just this morning, and it's about the different forms of copper-clad construction that you could use. Basically, ugly and Manhattan, and so I don't think he gets into any CNC stuff. Maybe he'll do that later. But in the first episode, he dealt with ugly construction and Manhattan construction. So we're glad to see Popcorn Electronics is back. Thanks, Todd, and thanks, Vasily. Yes. Um, and then Jim, KA4THC, he's in the Vienna Wireless Makers Group. He has finally got his Microbit X on the air and has been making contacts with it, both in single sideband and FT8. Congratulations on doing that, Jim. Finally, Farhan VU2 ESE, well, not finally, but Farhan VU2 ESE sent us a message saying that he had very fond memories of the homebrew dinner that he had with Wes and other HB heroes. I have the pictures of this up on the blog. I just stumbled across the pictures. And man, what an amazing dinner. There was Wes's son, there was Rick Campbell, there was Roy Llewellyn, there were a number of other prominent, Jeff Dahm was
Larkin.
there. Yeah.
Bob Larkin. Yeah.
Bob Larkin, a whole bunch of people there. Really, really good stuff. So Farhan was very pleased to see that. We got a nice message from Charlie ZL2CTM about his Pelican Case SSB rig. Charlie is a very admirable home brewer from down in New Zealand. One thing I really like about Charlie's approach is that he will not use a circuit until he has mastered the mathematics behind it, unless he knows how the bias circuiting is work, how the quiescent current is set, how the input and output impedance is determined. Really good stuff. Anyway, it was good to hear from Charlie. I'm glad that he's working on the Pelican Case SSB rig. We got a nice message from Walter, KA4KXX down in Orlando, and he was reminded from looking at some of the stuff that all new hams should at least build a transmitter. And he says that you could then use the SDR receivers that are out there. I don't know about that second part, Walter, but we'd prefer you to the hams to build the receiver also, which is what Dean is working on. But definitely with you on the transmitter portion. Finally, Dean mentioned some the nice people that are out there, and I got on 10-meter sideband the other day, and I heard somebody that I know from 75-meter AM. I listen to him almost every Saturday morning on the old military radio net. Even when I'm down here, I tune into the NA5B web SDR, and I'm able to listen to the Northeast AM chatter, and it's Buzz, W3EMD. He usually signs on 75 meters on 3885 from Rhinebeck, New York. And usually he's using, I think it's an Angry 103 or Angry 106 transmitter. And I could hear the dynamotor playing in the background. I could hear the running in with a dynamotor. It's really, really pretty good. I knew that would warm your heart there, Pete.
Oh, wow.
So great stuff. And I had a beautiful conversation with him. And then when I tuned in to the on WebSDR the following Saturday, Buzz was there, and I got a really nice shout out from Buzz on the via WebSDR on 3885 AM. So thanks for that. Thanks for that, Buzz. But Dean, you're absolutely right. There's some nice people out there. Guys, that brings us to the end. Holy cow.
Hey, I had two quick items here. One, Todd K7TFC just put out a new newsletter, mostly DIY RF, and he has the slot open. Anybody interested in purchasing a P3ST kit? They're taking orders, and I guess they're going to place an order in a couple of weeks. He has 105 transceivers across the globe, so there's another batch open up, and he also has a new set of boards for a Mars 6 SM Mimic amplifier. So someone interested in using the Mars 6, he's providing that board, so that's kind of cool. You know, when you're mentioning homebrew, Bill, one of the most amazing homebrew projects I've ever seen graced the cover of the ARRL sideband handbook, and that's Rudolph Fisher's ham band receiver with the HRO dial on it. And I got to tell you, that is some homebrew project. He's got a phase lock loop array in there, so it's got frequency stability. You see that beautiful. The receiver weighs 50 pounds. I mean, that's what he's got in there. So if you want to see an example of what you were mentioning, people in Europe tend to do a lot of these really exotic homebrew projects, and I immediately thought of Rudolf Fischer. So if you've got access to that book, take a look at that project.
I'll
Really
take a look.
something.
I have the book here. I think this is the book you're talking about.
No, no, it's got a picture on the cover. It's the
It's a
volume
different.
that has the volume of that has the engineer handband receiver. You'll see it right on the cover of the sideband
I'll,
handbook.
I'll check it out. Thank you, Pete. Dean, you have anything else for the group?
Got
Thanks,
nothing.
thanks, guys. Thanks for doing another solder smoke here, and we'll talk to you soon. 7-3s from Cap Cana in the Dominican Republic.
7-3 on the left coast.
And 7-3s from Great Falls, Virginia.
7-3, guys. Thanks a lot.